Okay, now comes the important part. Not that the other parts weren't important, but this is a difficult part, and this is where we go from cranking things out in SPSS to publishing those things, to writing them in a way that hopefully others can make sense. Those who don't understand statistics can walk away with a sense of what you found, and those who do understand statistics walk away feeling satisfied that you did the right tests and you did them in the right way. So I've written up here some thoughts and ideas that you'll want to include when you do homework number 3. But this is for the invisibility data set. Don't forget, homework number 3, we're using the spider data set, the people who saw the picture versus the actual spider. But in introducing what I'm doing here, somehow I'd like you to discuss the question. I mean, when Field collected this data, what was he interested in? In this case, I think he was wondering if people were more mischievous when they thought they had an invisibility cloak, when they thought no one would see them. And so he's got these two groups, and he's going to compare how many mischievous acts. It's the perfect setup for an independent t-test. And you can write that in your paper, independent t-test, because that's what we're doing this week. But then also here, Field talks about, or he doesn't, but I'd like you to talk about the alpha level. And we'll talk about this in class a little bit. The alpha level is the level of confidence that you'd like to have in your results. In other words, at 0.05, that means that 5 times out of 100, I'm willing to be wrong in order to be able to say something about what's going on with these cloaks. And 0.05 tends to be what we do in education. And so trust me for now. We'll talk about this a little bit more in class. But you need to choose this alpha level before you run your tests in SPSS, because otherwise it'd be too tempting to say, well, since my results came out at 0.08, I'm going to choose 0.08. That kind of feels like cheating. We've got to decide before we see what our results tell us. Okay, then we're going to talk about hypotheses in class. The null hypothesis, that there is nothing going on, and the research hypothesis that, yeah, the cloak tends to make people feel like they can get away with more mischievous acts. And so when you write your paper, you'll not be as succinct as this. You'll write more in words. And I would say, in my experience, 75% of researchers don't even put their null hypothesis in their paper. They figure that if they tell you their research hypothesis, participants are going to, we believe that participants will have more mischievous acts if they've got an invisibility cloak. Then you should be able to go back and say, okay, then the null hypothesis means there's no difference. There's nothing going on. The invisibility cloak does not make a difference. So you don't always type that in. Here's something else that your researchers, your writers don't always type in, and that's the assumptions. For the first few assignments, I'll ask you to talk about the assumptions just so that you get used to them, and then later we probably won't write as much about them. But sometimes a reviewer will come back and say, did you check the assumptions on your data? And you could write one quick sentence. The assumptions were checked, the assumptions were verified, or you might even skip that in your paper, because we assume that every paper that's published was published with data on which the assumptions were checked. And these are the 3 main assumptions: that you have independent groups, and that just comes from the researcher. Field would have to tell us, yeah, he didn't let the cloak group influence the no cloak group and vice versa. The second assumption, though, is that the dependent variable is normally distributed. And so we're going to show that by just eyeballing the this box and whiskers plot, and then also this histogram. And remember, we created these, we eyeballed them, and they looked pretty good. The third assumption is that the variances are equal, and this comes up automatically in the output. So here on my page, I've copied and pasted the output. Again, this is not something you would need to do, but I did this because I want to start talking to you about what matters and what you would put into your paper. So always include means and standard deviations for the group. And I've highlighted these in yellow. You'll find these in the first box that comes up in SPSS. Here's a mean, here's a standard deviation, and then I've written about these down here. So I have the mean of the cloak wearers was 5. I should probably put a space in here. The standard deviation was 1.65. And then the mean of those without the cloak was 3.75. The standard deviation was 1.91. Anytime we use an abbreviation for statistical figures, we need to put it in italics. So notice I've got SD here in italics. I don't have mean in italics because I did not use the abbreviation. If I wanted to put here, so M, the abbreviation for mean, equals, then I would also need to put italics. But you don't have to include the M here because it's a little redundant. I've already told you the mean of the cloak wearers was 5. And the mean of those without a cloak was 3.75. And we'll come back to this over and over again. Likewise, in APA style, for means and standard deviations, you put 2 numbers after the decimal point, and that's why this is 0.75 and this is 0.91. Even though SPSS up here, let's jump back up here, SPSS actually gave me 1 more decimal point on the standard deviation, but that is not APA style. Okay, so back to that third assumption now. Sorry, I digressed a little. That's in our next output, this independent samples test. So here is the F and the significance for that test. We usually almost never report these because they are confusing. All this tells us is we can read the top line. And so I could very quickly say here that Levine's test of variances showed no difference. And actually, instead of saying no difference, because the variances are slightly different, if the variances were exactly the same, then the standard deviations would be exactly the same, and they're not. They're a little different, but no significant difference. And the word significance is important here. That means I don't have to worry about them. They're okay, just the way they are. Okay, sorry, I've got Levy here. All right. We'll give Levine credit for this procedure he came up with. Now, once again, I've highlighted in yellow the things that matter here. So we have to report a T statistic, and this is it right here under the little letter T. We have to report a degree of freedom, and this is hit right here under the DF for degree of freedom. And we have to report a p-value. Now, SPSS calls the p-value SIG period, which is kind of confusing. That stands for significance, and the p-value tells us about the significance. What it's telling us is what's the probability that the null hypothesis is true. And it's telling us there's about a 10% chance that the null hypothesis is true. Okay, there's a 10.1% probability. Okay, so first of all, this p-value is two-tailed. And I am going to encourage you in almost every case to come up with a one-tailed research question. And that means in your research question back here, you have a word more or greater, not just different. They're not just different, because when we say they're different, that's two tails. Could be more, could be less. But we're going to say either more or less. And that's just one tail. And that's because we're the researchers, we're the experts. We know human behavior. We know that if people have an invisibility cloak, they're more likely to get into mischief. And so we can go with a one-tailed test. So down here is the math that goes with that one-tailed test. The significance, SIG, which equals significance, and I should put in here, which equals P. Okay, whoops, I didn't put the P in. So P is the symbol for significance, and I'm sorry, P stands actually for probability, and yet SPSS uses significance. It's a little confusing, but we'll get used to it. We'll do it over and over again. So P in this case equals 0.101. That's what SPSS gave us. But I had a one-tailed question, and so I can divide that by 2, and my actual significance is 0.0505. Think about that for a while. Come to class with questions because it's a new idea. It's a little bit difficult, but it's something we could get in behind the scenes and program in a one-tailed test here. It's way too much work. For me, it's much easier just to divide that number by 2. Divide it in half. That's my one-tailed significance. So now here's how I'm going to write up what I see in this table. An independent samples t-test showed no significant difference in mischievous acts, because that's our dependent variable, between the cloak wearers and those without a cloak. T, and here I've italicized the little t. It has to be a little t. It's not supposed to be large. And then in parentheses after it, I put the degrees of freedom, not in italics. So my T, 22, and someone who really knows their statistics will know this is degrees of freedom, and the rest of our readers will just have to hope they trust us, equals 1.71. Again, it's 2 decimals. P, my probability, in italics, equals 0.0505. We could add one more sentence here if we want. I cannot reject my null hypothesis. Yikes. Sorry, I don't even know how I spelled that so wrong. I cannot reject my null hypothesis, okay? And that is a problem. If this number was less than 0.05, if it was 0.04999999, I could reject the null hypothesis, but it's just barely over 0.05, and so therefore I am stuck with my null hypothesis. And I have to say basically that the group that wore a cloak and the group that didn't wear a cloak were basically the same. Now, one more thing I'd like to do here. Sorry, this is going to drive me nuts. Hypothesis. Okay. You can add an effect size to this. Now, in these few beginning weeks, I won't take points off if you don't, but eventually I'd like you to get in that habit. And the reason is, I have had several papers returned where the reviewers said, this is great, but you've got to have effect sizes. And my sense of publishing is every number's got to have an effect size with it. That's become a new requirement. And there's a reason for this. So our result was not significant, and I'm sure the reason is because our groups were too small. We only had 12 in each group. If we'd had 20 in each group with these same means right here, 5 and 3.75, our result would have been significant. That's how the math and statistics works. But then here's the downside to that. What if I could get 2,000 in each group, and all I'm asking is their favorite color? What's your favorite color? Or I guess I need something continuous. Shoe size. The shoe size of the cloak wearers, the shoe size of the non-cloak wearers. If I had 2,000 in each group, chances are very high the shoe size would be significant. And that, once again, that's a drawback of the math. Once we get huge groups, everything becomes significant, even nonsense. And that's why we've started to require an effect size. Along with significance, include the effect size. And oh, I was going to calculate this ahead of time. We'll calculate this in class. But the effect size is going to be 1.25 divided by 1.861. I had to go into SPSS and calculate a standard deviation for the whole group, everything together. And we'll talk about that too. But SPSS does not automatically give you an effect size, which I think SPSS could, and I wish it were programmed that way. Maybe that's something that will happen in the future. In the meantime, we just pull out our calculator or our spreadsheet and calculate it ourselves. But this might be a 0.65, I don't know, I'm just totally guessing, which is a moderate effect size. Effect, the noun. And so we could say, well, once our result's not significant, we can't say anything. But if it were significant, we could say, and the difference in the groups, you know, was there was a difference of about 1 act of mischief, which is a moderate effect size. I mean, you know, if you have an invisibility cloak, you're probably on average going to commit 1.25 more acts of mischief. So that's my first explanation of writing this up, and there will be more and more and more till eventually you can do it in your sleep. Good luck with this. Have fun with this. This is an introduction, and we'll talk about it a lot in class too. Thanks for watching these with me, and have a great week.